So starting with section 3 notes, we're going to talk about atomic radius, which translates into the size of the atom. So we're going to look at size. What is the size of lithium compared to carbon? What is the size of potassium compared to sodium? And then we'll look at something with that. So atomic size is a periodic trend that is influenced by electron configuration, which we've spent a lot of time on. For metals, the atomic radius is half the distance between adjacent nuclei in a crystal of an element. So pretend this is metal, pretend it's silver. If I have a silver plate, I have all these different atoms of silver that are very close together. So the atomic radius, it's just like in math, radius is half the distance of the diameter. So this would be the radius, the diameter would be 372, and also the distance from this nucleus to this nucleus would also be 372. But basically, when we're looking at atomic radius, we're using it to talk about the size. So if it has 186, that's the size of that atom. What's the size of a different atom? For elements that occur as molecules, so this would be like H2. So I have one atom of hydrogen attached to another, which would be written like that. But if I have a hydrogen molecule, pretty much the same thing. The radius, though, is in between the nucleus and where they actually come together. And the atomic radius of if I'm looking at a molecule, I'm actually looking at 2 atoms. So quite honestly, we'll get more into this later. For this chapter, we're focusing on 1 atom at a time. But this is how it would work when things start to chemically bond together. So, rules. And I'm going to read through these quickly, and then you're going to do something, and then we're going to talk about why this happens. So on the periodic table, atomic radius generally decreases from left to right. So remember studying, come back and look at this, but we're going to talk about the why of it. Caused by positive charge in the nucleus. Valence electrons are not shielded from increasing nuclear charge because no additional electrons come between the nucleus and valence electrons. How clear is that to you guys? How many of you say, woohoo, I totally get that? How many of you are, I have no idea what that's talking about? I would not, at your age, that would not make sense to me. But after we do our activity, we're going to come back, and the shielding part, I want you to understand. Atomic radius generally increases as you move down a group. This is the easiest one, and it will make the most sense to you. The outermost orbital size increases down a group, making the atom larger, which is kind of the Y part for this. And that might actually be... Here's a picture. So I can look at... It actually tells me the sizes, so where we looked at the diagrams a little bit, I can actually look up the picometers, which is a very tiny measurement, okay? Lithium's 152, hydrogen's 37, a lot smaller. Sodium gets bigger, potassium gets bigger, they get smaller. Here's the general rule for what happens to the radius. This, if you want to circle, I'll expect you to know those rules for the test. The numbers, I don't in any way expect you to know any of the numbers. And I'm not going to play that right now. That's where we're going to stop. Okay, so there's rules for the periodic table. Size of atoms change. I want you to take out your lab from last time. I'll do electron structure, which is actually atomic structure. So, one rule, size changes on the periodic table for some reason. Colors. How come if I'm going to be an element that has a color, I have to have an electron where?
In like transition.
In the transition, which is in which block?
The D.
The D block. If an element's going to have color, it has to have electrons in a D orbital, or a D orbital, D sublevel. If it has electrons in an S, it's not going to have any color. So that's one trend. Now we're looking at size of electrons. And I do want you to, because I did not mean to cross these out, it should be lithium, sodium, potassium. So the one that is crossed out should say potassium. And then one next to it should say calcium. What I want you to do on your sheet of paper is this. So I have lithium, sodium, potassium. What group, Austin, make sure you're still doing okay. Austin, what group is lithium, sodium, and potassium in? What group number? Just what group number? 1. So anything that's in group 1, I want you to actually put in group 1. Then I have beryllium, magnesium, calcium. Royce, what group are they in? Group number 2. So make sure they go under group number 2.
You want to just like put them in our periodic table?
I don't want them in the periodic table, no, because you won't have room to write. Hydrogen, where does hydrogen go? Group 1. Where does helium and argon go? Cool. Group 18 or group 8, whatever you can put 18. So this is what I want you to do. I want to write something that we're not using. So I'm going to put chlorine. Pretend, so I've got group 7.
Do you want this on a separate sheet of paper?
I want that paper that you already have information on. Yep.
On like the back?
On like the back would work best. So if I have chlorine, this is how I would write it. I would write chlorine, and then I would write, so find chlorine on your periodic table. Electron structure. What is the electron structure in your right-hand corner? Renee.
2